Hello, how's everybody doing today? My name is Noah Gift, and we're going to be talking about Python for DevOps. And Python for DevOps is a pretty cool topic in that it really is a very exciting, trend now. And I'm going to go ahead and share my screen so I can go through here and give you some of the resources that we're going to talk about here. So, as I mentioned again, name's Noah Gift, and I've written a book for O'Reilly called Python for DevOps. That's a fairly popular book, and some of the topics in that book I'm going to discuss today, and then I'm also going to walk through some of this information as well that you should have access to in the slide. So, in a nutshell, the schedule will be that I'll have several topics that I'll start with a poll, and then I'll go through those topics for a few minutes. And then if there's questions, feel free to go in and ask those into the Q&A widget, and I'm happy to answer those. So maybe to start with, let's go into this, which is your experience level. What is your experience level with DevOps? You can go ahead and I think we can even try this out in Zoom here. Let's go for a poll. And so would you say not familiar at all, somewhat familiar, very familiar? This would be a good kind of a sounding board here to see what everybody's comfortable with. So it looks like we have the results polling in here that a lot of people are not familiar with DevOps. Some people are somewhat familiar, and so it looks like we're kind of skewing through a combination of either not very familiar or somewhat familiar. So that's a good feedback loop for me. So let's get into this then a little bit here, and I'm going to go ahead and in this poll, and everyone can see the results here. Let's go ahead and share those results. So essentially, we kind of have a mixture of a few experts, and then basically everybody's either a little bit familiar or not familiar with it at all. So let's get into this. So what is DevOps? It's a combination of best practices in both development and operations, and many of the key technologies in DevOps include Python, which is optional, continuous integration, and then also continuous delivery, and then microservices. So it's worthwhile just talking through maybe from my perspective. When I was a CTO of a company for several years, or engineering manager in the Bay Area at multiple startups, that this turned out to be one of the most important things that I did in companies was to set up the continuous integration and also to set up the continuous delivery. And let me actually whiteboard that out and just kind of get into this and share what really was one of my main responsibilities at anything from Fortune 500 companies to smaller startups, is that at the heart of everything is this concept of Kaizen. And what's nice about Kaizen is that it's really independent of software. This is a Japanese term that means continuous improvement, and it's this feedback loop where you're constantly going through and improving things, and because you're going through and making this a continuous process is really a methodology versus some technique that you're using that maybe changes one day or the other. And at the heart of this continuous improvement process, we'll just say improve here, is that you're going to have a build server, and the build server is where your code is tested. So we'll go through and put this right here. We'll say build, and the idea here is that every time you make a change to something, whether it's the source code or it's the application, is that it's being tested. And this is where continuous integration comes in. So you may have heard this term CI, and CI or continuous integration is really just the concept of every time I make a change, I'm going through and I'm testing that change. And if you think about it, we use this concept many times in our day, probably, maybe right before you go to bed, you may double check the door, right? You may go, hey, did I actually lock the door to my house, or did we turn on the alarm system? Or if you leave your car, did I close the car door? This is kind of an automated testing process, so that you're going through and you're making sure that something works. Same thing with your software. If you're going through here and you're making sure that your software is automatically tested, what could happen is, on a daily basis, there could be, let's say 10 changes per day that happen in your source code, and you're constantly improving and making sure that those changes are actually still high quality, and everything is going well. Now, this is really the kind of the phase one, but then the phase two would be, okay, once I've tested it with CI, how do I do CD? And CD stands for continuous delivery. And this really is the concept of taking the thing that's already tested and automatically pushing it into production. And there's a phrase I like to use, which is, if it's not automated, it's broken. And that's really the concept with deploying your changes to a production environment, is that you're constantly going through and making these changes available, and showing people essentially what it is that you're trying to build, and actually really not worrying too much about being perfect. So let's go ahead and I'm going to stop this share and make it a little smaller here, so that it's not too crazy. Here we go. That should be a little bit better. So basically, with this concept of continuous delivery, you're not only taking advantage of the automated testing, but you're taking advantage of the continuous deployment of your code. So this means that the changes could go to a customer. So let's say that you're building a SaaS product, and your customer is, let's say using, let's say metrics, or maybe a marketing system or something like this, that your customer could be getting changes multiple times per day and then giving you feedback loop. And so it really goes back into this larger process of, instead of waiting for the perfect feature that's exactly fit, and you're waiting months and months and months, you're deploying multiple times a day. But each of those changes is a high quality change, and that high quality change is able to get out to the customer, and you're able to get feedback loop. So it's really the process of learning through a high quality feedback loop. That's really what the essence of continuous delivery is. Now, there's a couple other topics that came up as well, and one of them is this concept of microservices. And with microservices, one of the things that's interesting about it is that it's really the concept of a single purpose service. And in the old days, when you're building applications, there was this really more of a monolithic application, monolithic. And in the modern era here, what we really care about is that we want to have, let's say, an API endpoint that does, let's say it's a machine learning company, and they have something that predicts whether someone should get a new credit card offer. This is really going to do one thing. It's going to go to the customer, and the customer is going to get the prediction that says, hey, here's the credit card we'd like to offer you. And this is what a microservice is. It's a single purpose, lightweight type of style. And what's great about this single purpose, lightweight style is that it's much easier to debug, right? Because it only does one thing. You don't have to wonder if there's, let's say, other business logic that writes the results to a database, or other parts that pull in parts of the website or whatever. This is really an easier to debug system, and also deployment. Deployment becomes much easier because you're able to make just one small update to your code. So this is really the essence of DevOps as well, is getting away from monolithic, where there's basically all the logic is inside of this one application. And the downside of this, if you think about this from an agility standpoint, or if you're trying to do sprints or do things in an agile way, that it's much more difficult to figure out what's going to happen if you make a change to a monolithic application. Like, let's say you want to change the machine learning prediction, but then it turns out that everything is inside of this one application, and you could make a breaking change that affects some other part of the system, like the billing system. Like, let's say you're just trying to make a change to the machine learning prediction, but then all of a sudden the billing system breaks because everything's tied together. That's not ideal. And that's really why microservices are so popular. And this is a key component of doing DevOps. So just in a nutshell, I would say that several of the components here that are critical are continuous integration, testing, continuous delivery, the deployment, microservice, which is the single purpose application. And then the last one that I'll bring up, though, is kind of an optional one, is that a lot of companies are also gravitating towards Python. And so why would companies really gravitate towards something like Python for DevOps? And in particular, I think one of the things that Python does well is that it's a high-level language. And because it's a high-level language, it really fits quite well with those DevOps principles that we just talked about, which is single-purpose microservice, testing, automation. With cloud computing in particular, they have handled a lot of the scalability issues for you. And so with Python, you are just writing code that really glues together the cloud. And because of that aspect, it allows you to move very quickly. And so I think many organizations don't necessarily need to write in let's say a faster language like Java, C#, C++, or Go, because it's fast enough, and the cloud allows you to use services that are built in those languages. So if you're building, servers themselves, if you're building, the actual infrastructure, one of the ways that you would write that, I would recommend building a server in something like Go or Java or C# or something like this. But in terms of once the cloud service is already given to you as the customer, you may not need to build something in one of those other languages because you're only gluing on top of a high performance server. So that's really another kind of key takeaway with Python, is that it is a pretty good language for building on top of high performance servers. So that's really maybe phase one here. Let's also talk about another poll question, which is experience level with Python. So let's go ahead and ask another poll here, and let's go to polling, and let's go ahead and launch a new one. And let's see here. The next poll is experience level with Python. Let's go ahead and launch this. So would you say your experience level is somewhat familiar, not familiar, very familiar? Kind of let these questions come in here. It looks like things are trending towards somewhat familiar to not familiar, and then there are a few experts here. So we're getting kind of a similar skew. And so I'll go ahead and in this poll and then share the results here so we can see what everyone has got. So in terms of Python, as I mentioned, one reason for Python is that it's one of the most popular languages in the world. It goes back and forth between the most popular to the second most popular, third most popular, depending on what poll you look at. But this, from a management perspective, I think one of the mistakes that I've made in my career was at certain points not embracing the boring language. And what Python is boring because it's so widely adopted. And when it's boring, it means you can hire many people that know that language. And so I think this is a really key aspect that's overlooked, is that if a language is popular, it doesn't necessarily mean it's better or worse, or that there's some kind of controversial reason for using it or not using it. It's because you can hire more people. And I think from a management perspective, which I've had a lot of experience hiring teams, is that it's nice to be able to pick something that's the popular choice, so that you're not trying to hire, let's say, an exotic language developer like OCaml or Haskell or Lang or something very strange. And this is a very positive aspect of Python. Another one is that because Python has been around for so long, is that with Python, one of the things that's important about it is that really almost every possible kind of solution that you can think of, someone has done something for it already. And this really is useful in terms of microservices as well. And in terms of microservices, what's helpful about this is that you can actually go in and build out a library that or a microservice that uses the most of the code already from an existing library. So let's say, for example, you wanted to download some information from Wikipedia, right? You could write a bunch of code to do that, or you could just say import Wikipedia and then download this. And so this is really a huge aspect as well, is that not only is Python popular, but it allows you to leverage results from open source that, in a sense, really make developing solutions much simpler. And then what about a wide developer base to hire from? Again, we kind of talked about that. Really key problem in terms of the current environment we're in now. It's very difficult to hire. And if you pick the easiest choice, the most popular, that's going to be a good solution. And then, as I mentioned a little bit earlier, one of the things that's very unique about Python is that if you're going to build servers themselves, then it's not a great choice. But we don't really need to build servers anymore because cloud computing has already built those high-level abstractions for us. And it really is suited to gluing together high-performance code from other people. Now, the other one that's really interesting as well is that from an automation standpoint, it is really ideal to do things in Python because of the ease that you can write scripts. So let me just also kind of talk through this for a second about the cloud computing and automation and just whiteboard this out a little bit. Let's make this pencil a little bit thicker here as well. Let's do this. And let's go through here and look at a potential cloud architecture that I've built for machine learning pipelines, for example. So one thing that you could do is you could build something that uses, for example, SQS. And SQS stands for Simple Queuing Service. And this is from Amazon. And what's really neat about Amazon's SQS service is it has infinite scale. So really, you cannot break this thing. There's no amount of requests that can go into it or out of it that can break SQS. So from an application developer standpoint, what's awesome about this is that I don't have to build this high performance queue system. And in fact, I can develop architectures where the queuing will kind of be offloaded to some Java developer that has written, a really awesome infrastructure. And so the result here is that I could actually have a funnel of data just kind of pumping inside of this system. And then I could have a little piece of Python code, like a Python function right here, that could be, let's say, 5-10 lines of code. And this 5 or 10 lines of code can just listen as an event. And then it itself could, let's say, do 1,000 or let's say 10,000 requests per second would be trivial for this to work. And so what also happens in terms of cloud computing in Python is that because of these pre-existing systems here, you can build things leveraging on top of those high-level services. And I think this is not really discussed enough, is that it really has the higher level language you have, the better suited it is for building things in the cloud. Now, the other one that we were talking about was automation. And similarly, if what is automation in terms of software? Well, one of the things about automation with software in particular is that you're really taking something manual. So all automation is really a list of steps. So it's almost like baking a cake, right? Or making cookies or something like this. You're going step one, do A. Step two, do B. Step three, do C. And then what's happening is that you're actually just listing those things, and then you want to put those into a script. And with Python, it's trivial to put it into a file that's a command line tool, for example, called a script. And then inside the scripts.py, all it does is just go through those steps, right? So it would be like, building an automated robot that bakes cookies for you. The concept would be very similar. Let's say that the technology existed where there was a robotic cookie maker that you could buy, which I would love to buy one of those. First, before you automate the steps, you would need to do it yourself and measure out the ingredients, make sure that you've got the recipe correct, right? Okay, how many chocolate chips do I want? Okay, how much flour do I want? How much brown sugar do I want? How much butter do I want? And so what's interesting about this is that Python works very well in that kind of scenario where it's literally a sequence of actions, and then you go through and you script those actions. So really, that's from a high level, those are some of the key advantages of using Python. So let's go to the next section here, and let's talk about continuous integration. So we briefly discussed that, but let's kind of get a little bit more depth inside of it. So what is everybody's experience with continuous integration? We talked about it a little bit, what it is, but let's get some feedback from everybody and see what your experience level is. So it looks like we've got some pretty good feedback here. So I'm gonna let the poll in here. We'll go ahead and share the results. So it sounds like, again, we're kind of an 80-20 split here where there's a few experts and then a lot of people are not familiar. And in fact, what I can show you is I'll show you a slight teeny bit of technical work. And I think this would be helpful to you to see the concept of continuous integration. So if I go to something I did recently, for example, let's go to GCP. I think I have a repo here, GCP from zero. So here's a repository that has got an intentionally very, very simple workflow. And I have an application here which does almost nothing, right? Like all it does is have a Python function and it prints out a word. And what you do with continuous integration in a cloud-based environment or a SaaS-based environment like GitHub is that you can write a test, and here's a test file, and all the test does is say, look, does this word equal this other word, right? Because the function just returns back a word. And once I've had that test set up, what I can do is I can add some basic config file here, and it's really just like I talked about earlier, the cooking recipe. This is like how many chocolate chip cookies, how many chocolate chips, how much butter, how much flour. It's kind of the same thing. I'm just manually going through and I'm saying install all the Python software, check for syntax to make sure things are correct, and then run these tests. Now, how do I actually automatically test this? Well, if we click on this actions button here, this would be the build server. So it builds the software constantly. And notice that every time a change occurs, it goes through and it runs all these actions for me. And look, every single one of them was successful. But let's go ahead and break this. So I'm going to go to this test app here, and I'm going to break the test. And I'm going to say assert that Marco is equal to Marco. It should return back Polo. It's a Marco Polo function. Instead, it returns back, we're going to make it return back Marco. If I click this actions button here, you can go through here and watch it in action. And it's going to go through, it's going to install the code, it's going to lint the code. Both of those should work because I didn't do anything that would change the installation. I didn't do anything that would change the syntax, but the logic, the business logic is now broken. And we'll see this when we get to this step, which is test with PyTest. So let's go ahead and wait for this. And let's let this thing go here. There we go. So now you can see, look, it even tells us exactly the problem. It says, look, we were trying to assert that function Marco Polo returns back the word polo, but you told me that it returned back Marco. Marco Polo shouldn't return back Marco. It should return back Polo. So as a result here, I know that there's a problem. So in fact, even if you're not an expert and you've really never written code in your life, you could just go to this repository, create an account for GitHub, and you could click on this button fork, and you can make a copy of this and you could play around with it yourself. And the way you would do this is go to this test file here and just change the logic. And so I changed the logic that said right here that said it's Marco. So I'm going to change it back to Polo, right? So we'll say the function Marco Polo should return back Polo. Let's go ahead and change it. And again, we get to watch it in action and we get to see what's happening. It's updating. So it instantly triggers a new continuous integration test. And then we go through here and we can watch it in action. So really this is, I think, one of the most important steps at any company. I would argue to anybody in any company in the whole world that you should be doing some form of continuous testing. It depends on your organization, how much you want to do, but it's a very bad idea to not have this set up in your company. And there's no legitimate reason to not set it up. And even if you're a student or you're just a hobbyist, the reason to set this up is it saves you time, right? Because it automatically tests whether something works or not. Why would you not want automation on things that make you better, right? That's the whole concept of Kaizen. So that's it, really, in the concept of continuous integration, is that you can actually think of it about it as a very specific thing, which is I have some code, I test the code, it happens automatically, and it should be ubiquitous. There should be no software projects that don't have some form of automated testing. Now, there is a little bit of a business issue where if you go too far and you get too extreme and too maybe zealous about this, then it can be hard to maintain the test. But kind of a really basic level, like a syntax check or just some kind of basic testing, is only going to save your organization time. And that's really one of the concepts that's important to know about with continuous delivery. So the next, and so just to kind of go into the details here, continuous integration is automated testing, which we just did. It's a precursor, though, for doing the next step, which is continuous delivery. Just imagine, let's take water, right? Like if you look at modern civilization, one of the core components is clean water. And why is that? Because we know that water, if it's not clean, it could spread disease. There's all kinds of really bad problems that happen if your water is not clean. So it's similar with source code. Why would you push things into production that aren't automatically clean or tested? And that's really what continuous integration does. It's like a purification system for your software. So it's a requirement to do continuous delivery. It's also a mandatory best practice for DevOps. So if an organization says we do DevOps and they don't do continuous integration, they don't do DevOps, because this is required to do DevOps, is to have some kind of automated testing setup, because it, again, is the precursor to automatically pushing that into production. And as I mentioned before, I'm surprised actually how many people that I encounter and they don't do automated testing, even in their own projects, like maybe a sample project. And my kind of a comment to them is that it seems like you're saving yourself time by not doing automated testing, but you're actually costing a lot of time. And there's many examples of this where it's like a false dilemma, where you think you're saving yourself time, by doing something, taking a shortcut. A lot of times, though, a shortcut can actually take you a lot more time. And in this case, continuous integration is absolutely worth doing. So now let's go on to the next step here, which is continuous delivery. And again, we'll launch a poll here and see what everybody's experience is with continuous delivery. So we look at, I'm assuming it's probably going to be a similar kind of 80-20 type split, because continuous delivery is a more complicated part of continuous integration. Okay, yes, kind of what I was thinking. We have like an 80-20, 80% probably somewhat or not familiar, and then let's say close to 10% are actually familiar. So let's go ahead and share those results with everybody. So let's get into this again. So with continuous delivery, what are the core components of it? Is that code is always deployable, right? So it's never in a. Let's imagine that your family lived in a hurricane zone, for example, or somewhere where there's fires or there's some kind of natural disaster that's very common. A lot of people would then want to be prepared, right? You'd want to have a bag where you have maybe some food and some water, and maybe it's really easy for you to get out of the house and go somewhere else. So it's kind of the same concept is you don't want to leave certain things to chance if it's important. And code is one of those things where it always should be in a deployable state. It shouldn't take a week to get everything configured, and so you do one manual release. And in fact, that's probably one of the key anti-patterns that you could surface in your organization, is that if you're seeing that it takes, let's say, a week to deploy software changes, then there's a problem, and your organization should get to the root of the problem, which most likely is that there are brittle systems that are monolithic, or that there's not enough automation. But it really is I would call it non-negotiable requirement for modern organizations to be able to deploy the changes constantly whenever you need to make the changes. If it takes, again, I would say even more, anything that's not automated, it means that there's a process that needs to be refined. And another aspect of continuous delivery is that the infrastructure itself is defined as code. And this is kind of part of the issue here, is that in the old days of building software, when there was sysadmins and lots of IT people, that they're the ones, the humans are going through, they're clicking buttons, they're spinning up servers. But nowadays, in fact, all of that is actually a file where you configure the infrastructure. It's virtualized. You say, in this configuration file, I want to spin up multiple machines. They're going to talk to this other machine. So really, it's like a schematic or a blueprint that you're then executing that blueprint into production. So this is also a hard requirement for DevOps, is if you're not completely defining your infrastructure, you're not doing DevOps. Additionally, this concept of cloud native, in really the old days of building servers, if you're using a data center, there's things that really made it difficult to do full automation, and the fact that what if a physical piece of hardware dies, or how do you provision more capacity? And with the cloud, there are new concepts that are available that just didn't exist before. And one of them in particular was the example I showed earlier, which is SQS, which is a simple queuing service where you can infinitely scale the data up and infinitely handle requests. And really, in a nutshell, what cloud native can mean is really the ability to harness infinite capacity or near infinite capacity. And so if you're not designing your system to handle near infinite capacity, then you're not going to be able to do continuous delivery. And also with continuous delivery, it increases the productivity and the efficiency. So if you want to make your company more valuable to customers, one way to do it is to do continuous delivery, because they're constantly getting new updates and new changes. And you're going to be building things in a much more efficient way. If it requires many people to do something that's manual, to do deployment, then you're really being inefficient with your time, where it is possible to do complete continuous delivery for most applications. And so, yeah, we're getting down to the wire here. Let's see, somebody has a question here. Let's go ahead and see a couple of these questions. This might be a good spot for a second. Okay, let's see here. Let's look at a Q&A question here. So one question here is, does Kaizen fall under the second way in the three ways principle. The second way is about creating the right to left feedback loops. I'm less familiar about the so I'm going to go ahead and answer this live. So basically, one of the questions in the Q&A was, does Kaizen fall under the second way in the three ways principle? The second way is about creating the right to left feedback loops. I'm not actually familiar with that particular terminology, but what I will say is that Kaizen is related to something called the 5 whys, which is one of my favorite interrogation techniques. So the 5 whys is essentially a root cause analysis. And in fact, it's really fun if you're bored and you want to do something on a Friday, is if you want to figure out the root cause of a problem, you ask 5 questions. So let's go through a timely topic, right? So, question 1 is, for example, why is everyone at work, right? Like, so why is everyone everyone in the office? Why is everyone in the office, right? And you go through and you go, I don't know, why is everyone in the office? Let's figure out here, because we told them. Like, so, right. So, that's the next thing is we told them to go to the office. Well, why do they need to be in the office? Like in the office, what does that do? Well, we want them to do work, right? And, oh, well, but can't they do the work? And then maybe the next question is, can't you do the work at home? And then the answer is, you can. Like, if you're a software engineer, you can do it at home, right? And so this is a kind of a trivial, simple example of it. And then maybe the solution is, oh, actually, maybe they don't need to be in the office, right? So as an interrogation technique, you can use this for many, many different things in kind of doing a root cause analysis. And so it's very similar to Kaizen, which is that if you're always going through and you're asking, hey, why are we doing this? Why is it, and let's do one more 5 whys. So if we go in here and we say, for example, I used to work at a game company that it took 1 week to deploy changes to production. And I asked this 1 week to deploy a website change, like literally an HTML change. It took 1 week. And I said, why does it take 1 week? Right. So I go through again and I say, why 1 week? Why 1 week? And they said, well, because the team is only available on Fridays. Oh, okay. Why is the team only available on Fridays? And then basically they're like, well, it's so complicated to deploy that they need to blah, 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 blah. So it's complicated. They're like, well, why is it so complicated? Well, because we re-image the whole machine and we do this whole process, et cetera. And then maybe the next question is why do we do that? Why don't we just do a different way that's easier? And so again, it's kind of this concept of like, not in trying to be necessarily controversial or trying to cause a conflict, but let's get to the root of the problem and let's fix it so that every day we get better. Every day we get better. And so I think it may be related to that other concept as well. But to me, those Kaizen and 5 whys are very similar in that it's a great feedback loop to make continuous improvement. Okay, so another question here we have is, can you speak to the use of integration tests versus unit tests with continuous integration? So yeah, if we go back to this, if you look at this is again kind of a very trivial example, which you could have no software development experience at all and still kind of play around with this, is that let's look at this thing called a makefile here. And in particular with the makefile, one of the things that's important about this is that each of these steps is really related to a particular action inside. And so the first one is we install our software. And this is critical to automatically test the installation because packages may change or there's a new version I want to update. And so this is actually a feedback loop, right? Testing the software. And then there's the test itself, which would test the logic, the business logic, right? And that's what we just went through, which is the Marco Polo function. I I call the Marco Polo function, it returns back Polo, that means it's successful. If it returns back something else, it means it's not successful. That's a logic test. And then this one is a syntax check. And so they're different in that, let me show you, in fact, a syntax check and show you how it would change. So if we go through here and we go back to this application here, look at this thing that I have here. If I go through and in Python, I declare a variable and put 1 next to it, and then I take the variable and assign it to itself. So I do something that doesn't even make sense. Like, it doesn't really solve business logic. It's just kind of like useless code that's kind of almost like a time bomb that's kind of planted in there that eventually will cause problems later because I'll forget that I did something weird like this. Well, this is what a syntax checker will check. So I'm going to go ahead and commit this change, and let's go ahead and see what happens here. And so if we go to the build system here, look, notice that it was able to capture that. And then I go through here and I set this up, and we go through and we run this, we install the dependencies, we lint this code, we test this code. And in particular, what happens is, oh, look at this, we have a problem. And the problem is that this particular piece of code here says that you assign the same variable to itself, right? And that's what the lint does. Is it doesn't mean that the code wouldn't work in production. It would still work, but it's telling us something that's really a bad best practice, right? Like, it's an anti-best practice. And so it's catching an issue with code quality before it gets pushed into production and then permanently stays there. And so there's two styles of there's lots of styles of testing, but at a very, very basic level, there's the syntax check, and then there's the logic test. And in this particular example, we're seeing that there's a problem with the syntax, and we want to actually fix this. And so we can then, to fix it, we can go through here and we could just comment this out or delete it or whatever, and then this will kind of make things go back to normal. So they're, in my opinion, at the very least, even if you don't want to, for some reason, write a very small test for your application, at least check the syntax and have continuous integration going with the syntax checks, because there's never a good reason to push bad syntax into production. It's only going to it's the opposite of Kaizen, right? It's anti-Kaizen, which is it's continually making things worse by pushing bad syntax into production. Okay, so another question is makefile specific to GitHub Actions? No, all a makefile does is GitHub Actions doesn't need a makefile at all. In fact, I just use makefiles as like a recipe because it's simpler to define the steps. But you don't have to use a makefile. So for example, instead of, let's say that this is a command that runs the linting, I could go to my GitHub Actions here, and instead of the step where it goes make lint, I could just put in pylint and put that command there. I personally like to create like an abstraction where it's really simple and human readable, where I look at this GitHub Actions file and it says, oh, lint. Okay, it's human readable. Anyone can see it. If I put in a command, it might be harder to understand what's happening. So I personally think makefiles, which are available on Linux-based systems, are a great way to do automation. Okay, let's go to the next topic here, which is experience with microservices. So let's do the same thing. Let's kind of dive into this and figure out what everyone's experience level is with microservices. Again, not familiar at all, somewhat familiar, very familiar. And what I can do as well is just show you what a Python microservice looks like. So it looks like we're kind of a similar scenario, kind of still in the 80-20 of not familiar, somewhat familiar. So we'll go ahead and share those results. So the microservice here, if we look at this, I think I alluded to it earlier, it's a single function service, right? So it really just does one thing, and it allows for multiple languages in an organization as well. So this is another neat little concept, is if you have a monolithic application, so that essentially it's, let's say 10,000 lines of code or 100,000 lines of code, it's all in this one package. yeah, how could you possibly use other languages? It would be very difficult. I mean, it's not impossible. You could use languages that bridge to each other, but it would be very, very difficult to be having multiple developers working on it. But if it's all broken up and each one is a single function, it's possible. There are some people writing code in C#, there's some people writing code in Python, and because they have a clean interface, you can actually have multiple people working on an application. So this really is a huge innovation in terms of how to build services. Also talked about this as well, is that it's easy to troubleshoot your code when it's a microservice because it's just one thing, right? It's not doing tons and tons of things in terms of services, and you can go through easily and debug it. And really, it is does give you the ability to increase productivity and efficiency. And in particular, with a microservice, let me show you actually maybe like a machine learning microservice here. Let's go to, I have a repo called Python MLOps Cookbook. And this has a bunch of different machine learning code in here for a book I'm writing called Practical MLOps. And notice that this would be, I would say, similar to what a microservice structure would look like. You could have a makefile, the requirements, which are the code, maybe a command line tool, and then maybe a library that handles the machine learning code. But then in terms of the actual microservice, it would be like, let's say, a Flask web application. And Flask is a web framework in Python. And in particular, it would return back, if I scroll down here, something like this. So you would just say Python app like this, and then I would do a prediction, which would be a web service prediction, and then it would come back with a JSON payload, which stands for JavaScript object notation, essentially like a serialization payload that would give me back my result. And what's useful about this kind of a style is that it's really simple to understand what's happening. In fact, even if you're not a programmer, we can look at this real quick. Let's go ahead and look at the app, and it's somewhat intuitive. That look, there's all the code in Python fits on one page. We can make this even a little bit bigger, and this is what's great is this is just imports, right? This just uses code from another library, and then really the only thing that does anything useful really is just this: is we have a Python function that accepts a payload, and then it returns back that payload after it does a machine learning prediction. So what's great about a microservice here is that how simple it is to debug it. Like if I was needing to fix something or add more information to it or whatever, I can go right to it, and I can point this to somebody that's new to my company and say, look, here we go, from line 20 to line 27. There's 7 lines of code. This is where all the logic is. Go ahead and take a look at this and make a change to the code. Versus if it's 1,000, 10,000, 100,000, I've been in million line code bases with Python, believe it or not, is that it's a nightmare. It's impossible to know what's happening without weeks and weeks and weeks of kind of getting up to speed. But again, with this scenario, it's trivial to go through and just look at this and ask for somebody to make a change. So that's really the advantage of a microservice, is the speed at which you can actually go through and build out solutions. So another thing that's important about a microservice is, if we again look at this repository here, that a lot of microservices use a Docker file. And notice that how these Docker files can be very simple. And if you're not familiar with what a Docker file is, it's essentially packaging the runtime into production. And this often is a real problem. You may have even had this problem on a Windows machine or an OS X machine, where you're trying to install, even Microsoft Word could be something you're trying to install on something's different because you're on a new computer. And it's like, oh, this is so frustrating. How come this doesn't work? Everyone's had that issue. The same thing happens with microservices, where because the deployment system could be different or the runtime could be different, it causes issues. And so if you want to do continuous delivery, where you're pushing these changes into production constantly, you want to package the runtime together and push that runtime into production. That's really the use case for what Docker is. You may have heard this, or containers is taking the execution environment itself, the Linux execution environment, and it's pushing it somewhere so that not only do you have the microservice, the runtime, and the infrastructure defined, but it's all completely automated. So really, this is a revolutionary change in essence. And with microservices and infrastructure as code, so we'll call this MS for microservices, and then we'll do IAC, infrastructure as code. You're able to take, let's say, a small application here, and we'll call this the app. We're also able to take the runtime, which would be the Docker container. And then we also, so this would be like maybe the other circle, which would be runtime. And then the IAC right here, which would be the actual, different parts of the cloud that would be configured, would be maybe the outer layer here. Right here, we go through here and we say IAC. And then to script it, you would just have the deployment system right here, or that build system like GitHub Actions, for example, would go through and push that change. And it's 100% automatable, right? And that's really the key innovation that wasn't really possible even, let's say, 5 or 10 years ago, because the runtime was not able to be packaged together, which it can be with containers. The infrastructure as code was not really completely baked out, but now with cloud computing, everything is virtualized 100%. And as a result, you can have 100% automation of the delivery of software. And this is, again, a huge competitive advantage for organizations that can do this. And it really is I would call it a no-brainer for any organization to do continuous delivery, just because of the benefits, right? You're producing much higher quality code in a shorter period of time, and you're saving everybody's you're saving time, not increasing time, by adding this constant continuous improvement feedback loop. So that's probably a good spot here to see if there's any final questions in terms of Q&A. So let's see here. We've got what would happen. So we have somebody sharing a result here of Kubernetes voting app. What would happen? Another question is, what would happen to have an example of an end-to-end CI/CD pipeline as code? Oh, would you happen to have an example of an end-to-end CI pipeline as code? Yeah, I do have actually one that I can share with you. And in particular, I have one for Elastic, a couple of different ones, but we can look at Elastic Beanstalk, which is probably a good one to take a look at. So this particular repo here, which I can throw into maybe the chat here, give it to everybody. Go do this. So essentially, this Flask Elastic Beanstalk, notice the key components here. We have an application, really, really simple, like it does almost nothing, like a very, very small application. And then I have the infrastructure as code. And so this is the configuration that says, basically install my project, make sure that the project is syntactically correct, and then do a deployment. Now let's look at what that make deploy command does. If you go to the makefile here, all it does is it runs a command called EB for Elastic Beanstalk, and it does a deploy. And this would be deployed inside of the AWS environment. So this is the infrastructure of what it would look like, is that I could work, let's say, in Cloud9, for example, which is a cloud-based development environment, or my desktop, doesn't matter. I would hook up GitHub here. Then I would provision an Elastic Beanstalk environment, which is a platform as a service environment. I would actually push that change inside, test it out, make sure I get everything going manually. And then I would use a build server that's similar to GitHub Actions. In this case, it would be AWS Code Build, and I would push that change. So in fact, you can do exactly this. I have steps you can walk through one by one. And you could actually just, you can see there's some people that have already forked this. You can just fork this, run this inside of AWS, and it does a continuous delivery and continuous integration. That's a AWS one. I also have another one for Azure. If you're into Azure, I have one called Flask ML Azure serverless here. And if we scroll down, same thing, you can fork this. Notice how this works is that I have GitHub here. I listen for change events. I go through and I lint my code, test it, make sure everything occurs. I deploy to a web service. And you can see here, there's like a series of steps that walk you through it. So it's really the same concept. And I even have one for GCP. And if you want to go to GCP, I have one called GCP Hello right here. And it does a similar thing. There's a Flask app here where it has some code. And what I do is I use a cloudbuild.yaml, which is their build server. And notice that I lint the code right here. And then I deploy the code right here like this. So this concept works on all cloud providers equally well with Python. And those are all, 3 examples. Yeah, well, thank you very much. It looks like we're getting close to the end of the hour, but I'll stay around for a couple more minutes if you're interested. Feel free to connect on LinkedIn. That's where I put a lot of technical stuff. I also have a few resources on noahgift.com, but also there are many resources on Skillsoft as well. If you want to look at some of the examples of some books I have on there, I actually cover many of these recipes as well. Okay, let's see, anything else? Okay, yeah, thank you.